Okay, so we are on December 7th going over names and formulas for binary and polyatomic compounds. Okay, so I'm not sure what you guys remember, but hopefully you've got enough to where if I gave you the elements aluminum and sulfur, could you come up with a stable compound? Okay. I got one person nodding their head. Logan's nodding his entire body as it moves around. Okay. Actually, let me do
No.
Have you got these written on your periodic table? One of the videos I said to go ahead and put those on. So if you didn't, I really advise you to do it now. This will make your life a lot quicker. It'll help you memorize it because if you take the AP test, I'm pretty sure they won't give you that. And the multiple oxidation numbers, that's definitely covered in a video. So you might want to watch that, especially when we're talking the ones down here in yellow or highlighted. Okay, so while we're waiting, and since I'm kind of sitting here doing nothing, what is an elf's favorite Christmas music?
Elf's favorite Christmas music.
Yep.
Oh,
Rap music.
that was a good one.
That's what the site said, so we're good enough. Okay, so has everybody got that down? Because I want to make it to the time. Okay, very good. So with that actually, with it, and that's once again based on Lewis dots, figuring out metal, non-metal, losing all that. We have the metalloid stair step. So if I've got aluminum, find aluminum. Now, if you hadn't made the connection here, I've got the negative, sorry, put it on the screen, over the positives. Non-metals always take negative charges. That's why I have it above the line. Metals are always positive, which are below the line, below the stair step. So I did that as a kind of way to jog your memory. Aluminum is a metal, so it always has to take the green, has to take the positive. So aluminum is going to be a +3. Sulfur, it's above the line, so it's going to take that. It's a -2. So now we need to get to a stable compound. Okay. The trick, basically the easiest trick is called crossing down. Hopefully your teacher covered that with you. We cross down the numbers. So we'd end up doing that. And a way to verify, whatever that times that is, has to be the same number as that times that. Electrons lost have to equal electrons gained. Okay. And that's if one of them is a metal and the other one's a non-metal. Okay, that's the only way this works, because only if it's a non-metal metal, an ionic compound, will it ever have charges. So your formula for that would be Al2S3. Now, do you guys, there's only 2 capitals, so this is called a binary compound. Does anybody remember how to name compounds? Binary compounds. Okay, there we go. In the formula, the metals are always written first. The positives always come first. Okay, in the name, it's the same thing. So Al is aluminum, so we would call that aluminum. S is sulfur, but in a compound, I can't just call it sulfur because that's an element by itself. So what we do is the rule is basically you take everything, you drop the last syllable pretty much the last syllable, and you replace it with IDE. I've got to sharpen that round. So sulfur becomes sulfide. So if there's only two capitals, here's the thing. If there are only two capitals present, it will always end in "ide." Okay. Always. So that's why counting is good. You can count to 2 or 3, we're golden. Yep. So real quick, I'm going to skip number 2 for a second. I'm going to go down on number 3. Go from names to formulas, magnesium and iodine. What's the charge of magnesium?
+2.
+2. What's the charge of iodine?
-1.
-1. It's a halogen that's one step away from the full octet. Always check to see, do these add up to 0? If they do, you are done. If they don't, you do the cross down method.
Like in the MgI2.
MgI2. I put the 1 right now so you kind of see that, but in all honesty, just by writing the symbol, it's an implied 1. So you don't have to worry about that. So what would be MgI2?
Magnesium iodide.
Exactly. Exactly. Some of them sound a little bit weird. Sometimes we actually have to drop a little bit more than the last syllable, just because otherwise it's really weird sounding. So that would definitely be magnesium iodide. I'm just gonna move it over.
Okay.
We're okay?
Yep.
Okay.
Well, what would be the bond type? You haven't seen that.
Bond type. Okay. If one of them is a metal,
Oh, that's
it's a non-metal, it's always going to be ionic.
okay. And then there's covalent.
Yeah, the covalent, we'll cover a third type too, but right now the only ones you are familiar with are ionic and covalent.
Mhm.
If they are both non-metals, that's a covalent bond. Okay. Covalent bonds are a little bit, they're not as easy to figure out as ionics. You have to pay a little bit more attention to stuff. What you're doing with the Lewis structures this week are going to help you visualize some things. I'm going to take it back to Lewis dots. So I've got the Lewis dot for carbon. Everything wants to have how many dots?
8.
8. And metals are going to lose that however many they have to get back to the full. Okay. I'm going to go ahead and there's oxygen. Elements will share out the number of electrons they need in return. Oxygen needs 2, so it's willing to share out 2. Carbon has to have 4, so it's willing to share out 4. Covalent, co means share, or together. So what's going to happen, and this is the way I show it. You'll see it this way, but you also see some people circle the entire thing, which to me is kind of problematic. Okay. To me, when I circle the electrons, those are ones that are being shared between the two elements.
Mhm.
So if I look at this, oxygen had 6, plus I've also circled, I've roped in those 2 other ones. So there's its full octet. If I look at the carbon, it has 1, 2, 3, 4, and then the 2 that it roped in from the oxygen. So it's up to 6. But it must have a full octet. Here's the trick. Where you have one atom of an element, you have billions and billions and billions and so on and so forth. So would I need another carbon?
No.
What would I need?
Another oxygen.
Another oxygen. Now, I told you guys that we have basically kind of a pattern on Lewis dots. It helps for things, but all I've just did here is I just rotated it 180 degrees. It's still the same pattern, but it's a little bit easier to look at this way because now that oxygen needs two. So if I do the same thing there,
That's the full octet.
that carbon now has its full octet. And this oxygen now has its full octet. So with that, everything's good to go now. So we can just do the straight formula. Okay, well, what the rule on writing the formulas is, we're going to add to this later, but generally the thing that's furthest left and furthest down gets written first in nonmetals. Because carbon's furthest left, we write it first. There's some other stuff with carbon we'll bring in. So we're going to go carbon, then oxygen, and we have to say, hey, I got two oxygens. Now, in naming, if we're naming covalent compounds, we have a slightly different thing. We can figure out, if I just gave you aluminum sulfide, I know the charges that aluminum sulfur would come up with. I've got that on a table I can easily draw upon. So I can use that to figure out a formula. But with the covalents, there is no charge, there's sharing. So we have to have a different way to name it. Okay. And what we do there is we actually name using prefixes. And hopefully you remember your prefixes. Okay. And you guys already know part of it. What's the name of CO2?
Carbon dioxide.
Carbon dioxide. Di means two. So you already knew that naming system. So carbon dioxide. Now, sometimes you might see mono in front of the carbon. Generally, the first one, if there's only one of them, you don't put anything, you just put the element. Sometimes you may see them put one. I've not seen any like real pattern for that. Okay,
I have a question.
Sure.
Why is it magnesium iodide instead of magnesium diiodide?
Because
instead?
in an ionic compound, we're never going to use prefixes. That's a huge thing to make a note for yourself.
So prefixes are for covalent, whereas suffixes are for ionic.
Suffixes, everything gets, for a binary compound, if there's two elements, everything gets the IDE ending. All these so far have ended in IDE because there's only two elements involved. But the reason is because I've got a metal and a non-metal, we're having things lose electrons and things gain. In a covalent, they're only sharing. Well, if it loses electron, that means it's going to have a charge. If it gains electrons, it's going to have a charge. So we know what those are based on the electrons lost or gained, and we can create the formula just by knowing the name, because we know the charges of those different elements. So I could have automatically done this when I set it up because I know what magnesium is. I know what iodine is because that's coming straight off the periodic table. Okay. Let's try one. When you guys are tired of some of these, just let me know. We can move on. Okay. Let's go ahead and actually, do you guys remember your prefixes? Okay. Yeah.
Di, mono.
Mono, di, tri,
Oh, those.
tetra, penta,
Quinta.
hexa. And yeah, generally you don't see hepta. You could
Octa.
see octa. And you can figure 9, don't worry about. You can figure out 10, but you're never going to see it as far as I know on this. Deca. 9's missing.
Wait, why is 9 missing?
9 is because I don't know the prefix for 9 unless it's in organic chemistry. Organic chemistry, it's known, N-O-N, not non-known. I don't know what it is regularly, so I don't want to tell you something.
Mhm.
No. But known as only for organics, and we'll come back to those. So,
Sweet. That's the one I actually need to know.
pardon?
I actually need to do the organic chemistry.
Hopefully we'll get to the organic chemistry. Organic chemistry is a blast. Okay, so let's go through and do this. I want to look at this one. Okay. And you're going to see actually where if you have the formula, you can actually get the name pretty darn easy.
Sulfur hexafluoride.
Sulfur hexafluoride, exactly. The 6 is attached directly to the fluorine, nothing else. So indeed, I would just go sulfur. But hang on a second. I think you said one thing wrong. You said sulfur hexafluorine, but what do these have to end in?
I said sulfur hexafluoride.
Okay, you did say it right.
And 9 is Novem, like November. So with the BER taken out.
Okay, so novum. Novum.
Mhm.
Okay, I'm learning stuff every day. Novum. Yeah, okay. I've never seen that one. Okay, so sulfur hexafluoride. Okay. And sulfur's further left than fluorine. That's why we write it first. What about this one? NH3.
Mm. I don't remember the grouping things.
Okay, we'll do it this way. What's
But
N?
it's nitrogen. Nitrogen.
Nitrogen.
So we're going to start with nitrogen. Let's see if I can actually write with the correct side of the pencil. Now,
Oh, trihex.
if I ignore everything, well, if I ignore everything else, hydrogen, remember I said sometimes you take more than the last syllable?
Hmm.
Think about hydroide. Does that sound straight? Sound correct?
No, hydrogide.
Not hydrogide either. We actually
Hydride.
cut more. It's hydride.
Hydride. Okay.
Hydride.
Like high and dry.
Would it be-
Except it ends with a DE at the end of that.
Would it be nitrogen trihydride?
It would be tri because I need to include, in fact, there's 3 of them. So nitrogen trihydride. And let me give you, I don't know why I meant to have this one on here. We got this, and that's a 2. My 2s are kind of weird.
I'm still kind of confused on why these compounds are getting prefixes and suffixes, whereas magnesium iodide only got a suffix.
Okay, fair enough, fair enough. Okay, do me a favor. What is the charge of sulfur?
Minus
Negative 2.
-2. What's the charge of fluorine?
Negative 1.
-1. Now finish the sentence. Opposites
Attract.
opposites attract, good. So likes do what?
Hell.
Repel. Would these ever want to come together if they have charges?
No.
That means they can't have a transfer of electrons because negative means they both want to get electrons. Well, it can't get one from the other one when they're both trying to take them. What they can do is share.
So these are the covalent bonds, then.
These are covalents down here, yes.
And that the iodine to magnesium is a
Ionic.
bond.
Ionic. Because what you're going to see is where your metalloid stair step is. If the first element is one of these, it is ionic.
And
If you have
therefore,
one from this side and one from this side, that's going to be an ionic.
so covalent bonds get a prefix and a suffix, whereas ionic bonds only get a suffix.
Boom. Exactly.
Thank you. Sorry about that.
No, that's fine. That's why that stair step is actually kind of important because it actually gives you a focal point. if you're pulling from one from each side, you've got ionic. We're going to do that as a baseline. We're going to learn some additional stuff coming up, which is really going to mess with you. But this is just setting baseline. Okay, let's do this last one, and then we're going to move on to some other stuff.
Oh,
What's P?
phosphorus.
Phosphorus. The first thing we're not changing, we're not giving it any suffix, and I can't even spell. Okay. What's O?
Oxygen.
Okay, oxygen, and it's going to become oxide. Do you remember we need that IDE ending there?
Mhm.
But now I have to tell people how many of each one are there. So I need to tell people there's a 2 right behind that phosphorus. So what's the prefix for 2?
Di or
Di.
di, right?
Di. Has to be di. And then what's the prefix for 5? Because that's how many oxygens I have.
Is that penta?
Penta. Now, does pentaoxide sound a little weird?
Yeah.
Yeah, because you got 2 vowels side by side, right? So in this case, we just call it pentoxide.
Okay.
They try not to put 2 vowels side by side.
Pentoxide. Okay.
Diiodide is the only one that we really violate because you can't do much else. So does that work on going from names to formulas for covalence?
Yep.
Now we've got a trick on the ionics that hopefully you guys are going to remember. Okay. And I think I wanted to go. Yeah, we'll just do it this way. Okay. Got a different one. So I've got NaCl. What would I name that?
Sodium chloride.
Sodium chloride. Good. You guys are familiar with that one. What would I name this one? And you'll learn where they're at. Mn is number 25. And make sure you spell it right.
I might have to look that one up.
Manganese.
Manganese. Very good.
Manganese.
Mn, mang. People confuse that with magnesium, Mg.
Yeah.
So
Don't.
get that N and that G kind of straight. That's why I specify it in the name.
And would it be
Manganese what?
oxide?
Oxide. Very good, because I've got one from this side of the table and one from this side. So that means
it's
it's going to be an ionic.
Yep. Which means you don't have to put them out of stuff.
You're right. There's no prefixes ever in an ionic. At least binary ionics. Sorry, binary ionics. Okay. So you guys are familiar with that. That makes sense, right?
Mm-hmm.
Now here's the twist. What's the charge of manganese?
+2.
Okay, great. What's the charge of oxygen?
-2.
-2.
-2.
So it's 0.
Hey, Houston, we have a slight problem. 3
Houston.
times 2 is 6, right?
Mhm.
You agree on that one?
Yeah.
If there's no number written here, it's an implied 1. Well, 1 times 2 is 2. Does 2 minus 6 equal 0?
No.
No.
No. Some elements get to have multiple oxidation numbers. There's different things it can do on that stability pyramid. We talked about that. And on that, all of these guys here, and then all of the Ds have different options. I'm showing you how to figure it out in a formula. Later on, I'm going to show you how to do it in the name. So this is what we do. I'm going to start off without putting any charge up for the metal. Non-metals never change charges. Oxygen will always be a -2. So if I look, 3 times -2 is -6. I know whatever the charge of the manganese is, 1 times that value has to equal 6. Because I need this value total for this to be a true statement. So that means that manganese, that 1 manganese, has to have what charge to it?
+6.
Has to be a plus. It has to be a +6. Now, I need to tell people that. Because just like you said, you originally said, hey, it's a +2. And that is an option. But manganese, I believe, has 7 different oxidation numbers possible. We got to know which one. So with that, how I tell people that this manganese is a +6 charge, does anybody remember? No?
No, I don't remember.
Bella, are you on? Bella, you're letting me down here.
I'm here. I don't
You're
remember.
letting me down. How would I tell somebody that's got a +6 charge? I'm about to pound my head on the desk. Okay. Roman numerals, folks. Do you remember the Roman numerals? Yes. So I put the Roman numeral for 6, and that tells me the charge of the metal. This is that.
Yeah.
It only applies to the metal. Okay. So let's try that again. Let's try this one. Some are numbered, some are not, because I just pulled pieces off different worksheets.
Copper, fluoride.
Copper fluorine,
Fluoride.
copper fluoride, very good. Now, that's great that you've got that set up. Wonderful.
It's not done.
Not done. Always start with the non-metals. What's the charge of fluorine?
-1.
-1.
-1. So my total negative charge is a -3. That means it's gaining 3 electrons. How many coppers are there?
1.
1.
1. That means that 1 copper has to have what charge to cancel the -3?
+3.
It has to be a +3. So I know that copper has to be a +3 charge. So what do I do here? How would I let somebody know it's a +3?
Roman numeral 3.
Roman numeral 3. Do you
And
guys
why are
remember
we-
Roman numerals?
Yeah, we can figure it out most part.
Okay.
Why are we getting equal to 0 again?
Because electrons lost have to equal electrons gained. For
Oh,
an
yeah,
element to lose an electron, it's got to go somewhere.
Mhm.
And metals always lose, non-metals always want to gain. It's just got to
Okay.
be the same number.
Okay.
Excellent. Okay. And I'm going to actually throw you to the wolves on something else real quick. Okay, I'm going to write down 2 compounds, and I want you to name them both. Name both those, please.
Like in our journal or out loud?
Just on paper.
Okay.
I want to make sure everybody gets a chance to get these. Okay, we got them?
Yes, I believe so.
Okay, great. So PB is what one?
Lead.
Lead. And you guys are going to get these memorized very quickly if you don't already have them done. So PB is the same in both. O is
Oxide.
oxide. So put those in. And we notice there's a slight issue.
Mhm.
If I said, hey, go grab that bottle of lead oxide, and if it sounds like we're going to be able to get together second semester so we can actually get some labs done, which is awesome. Would you know which one to get me?
No.
No, because right now they're carrying the same name. This is where we must have Roman numerals. And we always build it from the non-metal back. And these are only the ones you have to worry about. Are these guys? And then these.
Mhm.
So oxygen's always going to have a what charge?
-2.
-2. So that means my total negative charge here is going to equal -4.
Mhm.
I know it's got to equal 0 because electrons lost, electrons gained. There is one lead atom. What has to be the charge of that single lead?
+4.
It has to be a +4. And 4 is 1 less than 5. B is 5. So it would be written as that. Let's do the same thing on the other one. Oxygen is still going to be a -2. It always has to be. There's one oxygen. So in this case, the oxygen is going to carry a negative charge of 2. What would have the charge of that single lead?
+2.
Has to be a +2. Because it's got to cancel that, just like up here, the 4 had to cancel. So in that case, I would tell them it's a lead Roman numeral 2 oxide. Or a lot of times you'll just hear them say lead 2 oxide.
Mhm.
Okay, does that help? Do you guys kind of remember that?
Yeah.
stuff?
That
Okay.
makes sense.
I have a follow-up question about that.
Yes. Yes.
So with the understanding that you can have like lead, then for the oxidation level for oxide, how do you differentiate that between like lead 2 as in 2 lead oxide?
That's going to be based purely on the charges. Let me see if I can come up with an example where you would have that. Actually, I can give you this one, which is kind of where we were heading. Anyways, okay. I'm going to have to use a slightly different value, slightly different thing. And we'll do it that way. Now, on this, for me, actually, anytime you see 3 or more capitals, you have what's called a polyatomic compound. Poly meaning many, many atom compounds. And we're talking elements. Okay. The polyatomic compounds I've given you down here for a reference. Okay. I don't think AP gives them to you. I don't know. I haven't looked that far into it because I always do. I do one additional thing for my students. I will always put the polyatomics in parentheses if it's something I make. It just helps you visualize and process it quicker. Some books you're going to find out don't. In that case, you're going to go through, and if you were to see this, actually, hang on a second, this one's going to have it. I'll give you a case in a minute that won't. Okay, we'll take care of that in just a second. Okay. I don't want to jump through too many different things. Now, PO4, it's in parentheses. So jump down here, and what's the name of PO4?
Phosphate.
Phosphate.
Mhm.
Now, what's the charge of phosphate?
-3.
-3, and it will always be a -3. So my total negative charge is going to be a -6. but I know whatever the charge of the positive has to be, has to cancel out of 6. Well, 3 times what
Plus
is going to
2.
be 6 plus 2? That means I've got multiple leads, but it's based on the charge that I care about. Logan, did that make sense? Did that answer your question?
So in writing that out, it wouldn't be PB3 and then the Roman numeral 2. It would just be how you wrote it out originally.
No, I take that back. Because lead can have multiple, yes, it would be a Roman numeral 2. I'm sorry, I thought you were going to say something different. So it
It would be
would
Roman numeral 2 and then 3 under that.
nope. I
That
don't
Roman-
worry about
Okay,
these.
that Roman numeral 2 means the plus 3 right there.
This Roman numeral 2 means that. Roman numerals are always charges. And here's the thing. Think about it this way. Let's say I gave you this. Could you tell me the formula?
Lead for chloride.
Okay, well, could you tell me you said lead 4 chloride. How would I write that?
Lead Roman numeral 4 chloride.
Okay. Actually, when I was talking about writing the formula. So what I was looking at
Oh,
for you
yeah,
to-
I can do that for you.
for you to tell me PbCl4. That's what I was looking for you to tell me. Now, in the name, you actually said the name right. Lead. I have to tell them the charge of the lead is a +4. There's my Roman numeral. Because lead could be multiple. I've got to tell them which one it is. And then chlorine becomes chloride. Does that make sense? Okay. Now, going back to the reason this was in parentheses is because you had multiple of them. Sometimes you may see, that's a common one you'll see at times. Now, there is a polyatomic present because of the fact there are more than 3 capitals, or there are 3 or more capitals. Now, with very, very rare exceptions, all of the polyatomic ions are negatively charged. And the negatively charged ions are always written last. So if I pull off the very first thing, which is going to be a metal, whatever's left is my polyatomic. Doesn't matter how many of those polyatomics, I'm just saying that, or excuse me, how many of those metals. I cover that, whatever's left is my poly. So in this case, Na, sodium. What's NO3?
What's NO3?
What's NO3?
Would that be nitroxide?
Okay. Now, no. And that's actually one of the things that I normally see.
Nitrate?
It's nitrate. Here's a reason
Oh.
I give you guys the parentheses.
Mhm.
Because if it's in parentheses, it's automatically down here.
Oh,
Because that's one of the ones that's cut out on our sheets.
Yeah. Well, that's what you were supposed to have written in earlier, man.
I did write that in. That's why I got it. I was just saying that might be the reason why we
Yeah.
missed that.
Okay. But once again, is when you go through, if there's 3 or more capitals, cover up the metal piece, the positive. Whatever's left is going to be your polyatomic. If you
Okay.
put it in parentheses, that's going to help you track it.
okay. And the polyatomic is just helps you find the name.
Find the name, and later on, we're going to go from names to the formulas.
Okay.
So you're going to need to, one thing I need you guys to realize is notice you've got NO3 here as nitrate. If you go up to the top of the next column, you have nitrite,
Mhm.
NO2. It has an ITE ending. That's how we differentiate between eights. Notice
Mhm.
this has 3 oxygens. This has 1 less than normal. That's why it picks up the ITE ending. You have sulfate SO4. Well, sulfite is SO3. We took away an oxygen. You can have phosphate, phosphite. And we'll get into that part of the naming stuff later. There's also hypo that we can throw in. Okay. So we're okay on this piece?
Mhm.
Yeah? Okay. No, it shouldn't. Okay. Now, I can combine them. What would I name CrNO3 3? Come up with that on your own, please.
Oh.
And after this one, we're going to move on to the names to formulas. I hate the fact that colored pencil doesn't erase.
Yeah.
That's what you guys need to do to make a million is get colored pencils that actually do erase, not smudge. Okay, you guys got it?
Mhm.
Okay, survey says?
Well, I'm not.
Sweet.
Yeah, because chromium is one of those Ds and Ds can have multiple. Automatically, we've got to have it. So hopefully that makes sense on going from formulas to names.
So,
Yeah, go ahead.
so that 3 outside the parentheses, that applies to the charge of the nitrate?
Nope.
What does that mean then?
Okay, which 3? I've got this.
The one
this.
after the nitrate.
Oh, that?
Yeah.
I'm sorry. Yes, that applies to the nitrate only.
Okay, that's what I was confused about.
Yeah, it's saying I have 3 of whatever's inside the parentheses.
Okay.
That's what that's telling me. Okay, I'm sorry, I messed up what you're saying. Okay, so formulas to names, we're good to go. Now let's go names to formulas. Silver is Ag. Bromate, I highlighted the 8 or made it bold just so it stands out more. You won't see that normally. In fact, that you won't see that normally. I do that to kind of train you guys into that. What's the formula for bromate? I think that one's on.
ErO3.
There we go. Okay, now what's the charge of bromate?
-1.
Okay, so silver is in that middle section. Silver's right here. It can have multiple charges. How do I know which one it's going to have? I've got it. All I got is a name. How would I know what charge it's going to have?
It needs to equal 0.
It needs to equal 0, but I'm creating the formula. I don't know how many are there already,
That's true.
but you already know the answer.
The Roman numeral, it's a 1.
Boom. That's a Roman numeral 1, right?
Oh, that gives you the charge.
That means that silver will always have the +1 charge in this compound.
Mhm.
+1 - 1, what does it equal?
0.
We are done.
Awesome.
Let's go to the next one.
Fe.
Fe, great. Can you tell me anything else about the Fe?
+3 charge.
+3, because the Roman numeral always applies to what's in front of it. Now, there's a mistake I expect to happen because it always does around here. Some people make it, some people don't. Finish it out. I don't know why I'm so angled here. I'll just move the camera easier for me. Got it yet?
Yeah.
Okay, some people are still working. Okay, how many people found hydroxide?
I did.
Okay, how many people have it as H
Not me.
or O?
Almost. Almost.
Almost. Here's the one thing. Hydroxide catches people because of that IDE ending. People think automatically it's a binary, but it's not. And here's a way to remember. If you were to see hydro, what element would hydro make you think of?
Hydrogen.
Hydrogen. If you were to see oxide, what element would that make you think of?
Oxygen.
Oxygen. Hydroxide, and the name's kind of misleading, is actually the polyatomic OH. And that actually has to deal with bonding as to why the O is written first in this case.
I was sitting here for a fat minute trying to figure out what number hydro was, like it was a prefix. Like,
Yeah, it's one that catches people. So I'm trying to give you guys the heads up on that. So what's the charge on hydroxide?
-1.
-1. Now, does this add up to 0?
No.
No. So that easiest way is we now cross them down. About rotor T there.
Oh yeah.
So it would be FeOH3. Good. I've got one coming up there, one deal. Okay. Mercury, I'll give it to you. Hg, what do I know about it?
+1.
+1 charge coming from that. Sulfate. What is sulfate?
SO4 -2.
SO4 -2. Excellent way to say that. Does it add up to 0?
Nope.
No, electrons lost must equal electrons gained. Easiest way to do it, cross down. You're going to see in a second, there's a caution to that. 2 times 1 is 2. 1 times 2 is 2. Good to go. Now, lead, what's the symbol for lead?
LB.
Pb.
AB. Yeah, my bad.
What's the charge of lead? Because you can have multiple.
+4.
+4. And I don't know if I can clear this. Yes, I can. Good. Okay. Now, carbonate. What's the formula for carbonate?
CO3 -2.
CO3 -2. Excellent. So, doesn't add up to 0.
No.
What do I do? Now, if you're thinking cross down, which is what we've been
Yeah.
doing, that's a good start, except you have a problem. These numbers down here are ratios. This is saying for every 2 lead, you need 4 CO3s. If you try to give your math teacher a ratio of 2 to 4, would they be happy?
No.
You always have to do with ratios.
Simplify.
You have to simplify. We do the same thing.
Hmm.
In this case, we divide them both by the smallest. That's how we get it. It becomes a 1 to 2. 1 times 4 is 4. 2 times 2 is 4. If you cross down, great. Crossing down works. The one thing you must check is if it can be reduced. If it can, you must.
Okay.
Okay, let's go to this one. These actually get easier. Nitrogen is what?
And
And hey, the first one's over here. It's a non-metal. If the first one's a non-metal, guess what I'm using? Prefixes.
Prefixes.
Never charges. If the first one's a non-metal, I'll never have charges.
Mhm.
And I don't need them because of the fact that I generally are going to have prefixes.
NCl3, right?
So I've got chloride as chlorine. And yeah, this is telling me I have 3 of those. So it'd be NCl3, exactly. Come up with the next one. You'd be surprised how many people are killed by this substance every year.
I had a whole job about protecting against it.
About what?
Protecting against it. Prevent people from dying in it.
Yeah. The thing is it's something we've got to be exposed to. We got no choice.
Yep. No choice for that one.
Okay. So hydrogen, we got oxide is going to be oxygen. Now it tells me dihydrogen. I have 2 hydrogens. How we say we have 2 of something or multiple of something is we put the number behind the symbol. Mono means 1. Do I have to write the 1?
No.
No, it's implied. I can if I'd like to, but I don't have to. Okay, dinitrogen trioxide. What have I got?
N2O3.
N2O3. Excellent. Di means 2.
I'm unmuted.
Tri means 3. Do you see how those actually go quicker because of those prefixes?
Yeah.
Yeah, they're a lot quicker, but you've got to remember the prefixes. And any other questions?
No,
Want to work a few more? Are you pretty much good?
I'm good.
I'm good.
And here's the thing, okay? You have to be able to come up with these, and they have to be basically true because you're going to be getting masses for these. Because when we go into the mathematical calculations, molarity, stoichiometry, and all that, you're going to need to have masses for the compounds.
Okay.
If you would have had this, if you would have had this instead of this, do you think they have the same mass?
No.
No, automatically you've missed points and your answer is not going to be right. There's no way it can be. It's like if you forgot to put a 3 here, your mass is wrong. You've got to be very careful with this stuff, very methodical on it. If you need more work, you can go through on my, there's videos on the YouTube channel. Do you guys remember what the Swift pages are? Remember when teachers used to have Swift pages? I have a Swift page, and I think you can still access it through the district. If not, I'll try to send out a link. I'll make myself a note now. And on that, under the documents, if you search for like names and formulas, something like that, a lot of times I'll have a worksheet and then I'll post the key with it. So you can test yourself and check yourself. Or I can send you worksheets from here, just ask.
Is Swift even still up and going?
not to where we can add stuff to it, but they haven't taken it away yet, which is good because I've got hundreds of documents on it. So,
That site works completely off of PDF, so it should be able to, if I remember correctly.
now it depends on what they saved it as. Mine are docs.
No.
So, but with that, and also, did you guys get an email from me this morning or from a site
Yes.
telling you?
I was
Please
going to
do
ask you about that.
Yes, please do so. Because that's an online homework site, but also I can do quizzes to kind of show you guys what AP is going to be running like. Okay, so it's going to actually put you guys to your paces and give you more practice on stuff. But I'm trying to give you as much resources as possible. Sound good? Okay, so with that, thank you guys. Hopefully that helped, and I'll see you tomorrow.